Hello, today's lesson is an introduction to exponents, and we're going to need these for an upcoming volume unit. So these are the terms we need to know. The word base, exponent, exponential form, also known as exponential notation, power squared cube, evaluate, standard form, our standard notation, and an expanded form are also known as factored form. So let's look at what we have. It says the number above is written in exponential form or exponential notation. You can say either. Using the number in exponential notation as an example, answer the following. Well, the base, if you think about B for big and B for base, the base is 6. It's the big number, so to speak. And the exponent is 3. It's the smaller number that's called superscripted, which means above the number. And we read that as 6 to the third power, or we could say 6 cubed. That's kind of a nickname for it. And we'll talk about that when we get to volume because we're going to be using 3 dimensions. It means 6 times 6 times 6. Or if you'd rather write it with a dot or times sign, whatever helps you, that's fine. And so when we write it out the long way, this is called expanded or factored form. And this kind of makes sense to my brain because I see it being the longer way to write this, expanded. And factors are what we use to find a product, the result after we multiply. So let's explore this. These are all written in exponential form. And then we have to talk about how we read it. And then we're going to try to write the factored form or expanded form. So this first one is written as 3 to the 6th power. That's how we pronounce it. And then we can write it as, we're going to see 6 3s all being multiplied. It doesn't mean 6 times 3, but this number means how many times we are going to see the base being multiplied. So this next one is written as 7 to the 4th power. And that means 7 times 7 times 7 times 7. This next one, they haven't given us the exponential form. So let's look at the factored form. That's going to help us answer both of these. So the base is 10. So we would write this as 10 raised to the 5th power because there's 1, 2, 3, 4, 5 tenths. So that's the power, and then 10 is the base. So we're going to write that as 10 to the 5th power. Would you please try the next two on your own and replay this video when you're ready? All right, so we should have 4 to the 2nd power, and we see that it's 4 times 4. You're going to notice it says or. Well, this is special, and we also refer to this as 4 squared, and I'm sure you've heard that in the past. And then 5 to the 3rd power, again, we can write with a dot, with a times sign, or with the parentheses. 5 to the 3rd power also has a special way to say that, and this would be 5 cubed. And once again, we'll need this for our volume lesson. So now let's go on to our next page. So for this next one, you might want to have your calculator ready. That's going to help you. And it says we can blank, which means find the value. So that's the word evaluate. That's one of our vocabulary words. Evaluate means to find the value of the expression. And we can find it by finding the product, which means the answer, of the factored form. And once we evaluate it, we write it in standard form. So another vocabulary term. So standard notation or standard form. So So write the following numbers in factored form and then evaluate it. Write the answer in standard form or standard notation. So if I look at this, now I have to expand it or write it in factored form. So I'm going to see 2 times 2 times 2, that's 3 of them, 4, 5, and 6. So that's expanded form. So pause and use your calculator and multiply 2 times 2 times 2 times 2 times 2 times 2. And you should get 64. That standard form means the way we'd rather see our numbers. Our next example is 1 to the 5th power. So we're going to write that as 1 times 1 times 1 times 1 times 1. Again, we try to avoid the times sign because it looks like the variable x. So if I multiply 1 times anything, it's going to be that anything. So 1 times 1, all of those ones, it's still going to be 1. So would you please take the time to write these, stop the video, and then find the standard form and replay when you're ready. All right, so here's our expanded form, and here's our standard form. And let's discuss this one. If we are given a number, and this will become important later on, if we're given any number, then there's an implied 1, a power raised to the power of 1. So if we don't see a number, if we don't see an exponent, then it's 1, not 0. My inclination, and probably naturally we'd want to put 0 there because we don't see anything, but we always want to include a 1. And so this makes sense. If I had 1/16, it would be 16. Now we're going to use the power of that calculator. There's lots of good things a calculator can do for us. So here are the steps we can use to evaluate a number in exponential form raised to any power. So I'd like you to circle any power or highlight it, whatever you need to do, because there's also another way we can do this for certain powers. So we're going to write down that we first put in the base, whatever number, the big number, B for big, B for base. Then you're going to find this key on your calculator. It is on standard or on the Texas Instruments 30X. It is the 5th key down in the first column. And then you're going to put in the exponent. And finally, you're going to press enter equals, and it will evaluate it. So try those steps using 5 as a base, and sometimes we refer to this as the caret key, then the exponent of 4, and then equals to see what you get. You should have come up with 625, and so I'd like you to try B and C and then play the video when you're ready. Now you may have been surprised how big these numbers are, and if you've ever heard the term exponential growth, that it grew exponentially, meaning it got large quite quickly. That's what happens when we raise a power to, if we raise a number to a power, each power we continue with, we're multiplying that product, and so it gets larger very quickly. If you wanted to go ahead and put the factored form of this in to prove that it's 4,096, you can. All right, I mentioned this a few minutes ago that I wanted to highlight any power, and we use this key for any power. When we raise a number to the second power, which we refer to as squaring a number, we can use the same process just as we did on our calculator, or we can use a special key. And because we use the squaring quite frequently, it has a special key. So once again, you'd put the base number in, the big number, and then this is the special key we're referring to. It's right below this key on the calculator, making it the 6th key from the top, and then we press enter or equals, and that will give us the answer. So would you please put an 11, press this x squared key, and then enter, and you should get 121. Would you please do E and F now? And replay the video when you're ready. All right, did you get 9 for F? If you chose not to use this, you might have thought this was 3 times 2. That's very common, and often students will write 6 here. If you use this key, though, it does mean 3 times 3, and it will help you to use that key. So continuing to the next page, it says evaluate the following using factored form. So we're given a series of -2's raised to different powers, and it wants us to write the expanded or factored form and then standard form. So as we discussed earlier, when I have something raised to the first power, that's just like having just that number, so -2. And that standard form would be -2. Next, I'd have -2 times -2. So if you recall, a negative times a negative is a positive. So we're going to get a +4. Next, we'd have -2 times -2 times -2. So let's think about that. -2 times -2 is +4. So +4 times -2 would be -8. So I'd like you to continue working on, and first please, for this exercise, please write everything in factored form, and for right now, please enter it in factored form. We're going to have a discussion about it later, about those parentheses. Replay the video when you're ready. So please check to make sure that you have written down what I have written down here. So this question says, what do you notice about the products of the numbers that had an odd exponent? So let's identify the odd exponents. Well, 1, 3, and 5. So we're looking at the product, -2, -8, and -32. Well, they're all negative products. Our next question says, what do you notice about the product of the numbers at an even exponent? So here's the product, standard form, and let's highlight the even products and even exponents, rather. So these even exponents, and it should have been even exponents, not even products, all of them are positive products. And those are both very important concepts. If we have an odd exponent, when we have a negative base, we should get a negative answer. If we have an even exponent on a negative base, these are all -2's, all of our products should be positive. Did you notice the parentheses around the base? When we're given a negative base, we must enclose the number inside the parentheses. So let's write that. We must enclose the negative in the number base. Let's put base inside parentheses. Should be an E. And it says, using the special keys on the calculator that raise a base to a power, let's explore what happens without using the parentheses. So we already know that these are the products. So let's go ahead and see what happens if we don't do this. So I'm going to have you write -2 without the parentheses, and I want you to raise it to the first power. So would you please do that? And what I'm talking about is you're taking -2, you're raising it to 1, to the first power. And you should get back -2. Now let's try -2 without the parentheses and raise it to the second power. So you're going to put -2 and you're going to raise it to the second power. But what you're going to get back is going to be -4. And when we look, we should have gotten +4. So let's try this 2 more times. Let's take -2, raise it to the 3rd power. So you put -2, raise it to the 3rd power, and you're going to get back -8. And now -2 raised to the 4th power, your calculator will say -16. And what happens is we should have gotten +16 when we put it in expanded form. And this is correct. All of what we did up here is correct. So what happens if you don't use the parentheses, your calculator sees that negative sign as being separate from the number itself. So it will put that outside and do this. So it's as if you're taking this on each one of these. That negative sign is kind of detached. And when you work with the odd exponents, you get the answer you expect, but when you're working with the even exponents, you do not get the answer that you expect to get because that negative is kind of hanging outside. So here's what we need to do when we're working with the calculator and we're trying to enter it in exponential form. For the following numbers, decide whether the product will be positive or negative based on the exponent. Then evaluate the numbers using your calculator. You must enclose the base inside parentheses first. So here's what's going to happen. We're going to have to put our first parentheses, find that on the calculator, it's about midsection of the calculator. Then we're going to put the negative sign, and that's down at the bottom. There's a little white key down at the bottom and close parentheses, the negative key. And then we're going to have to put the base, and then the second set of parentheses that encloses it. We're going to put this key that raises it to a power, and then finally we put the exponent. So if you need to pause and write this all, that's fine. So let's look based on what we talked about above when we have even and we have odd exponents. If I have a negative base and an even exponent, I'm expecting the answer to be positive. And here I have a negative base but an odd exponent, so I'm expecting the answer to be negative. So would you please evaluate all of these using these keys on your calculator and then write the answers. So I know this video has been extraordinarily long. I had hoped to be able to do this in person, and when we meet again, we will go over these answers and start from here. Thanks for listening. Have a great day.